Hello students, let's continue with gravitation. Now, continuing with the gravitational law, we'll understand first in this module the characteristics related to the gravitational law and then the very important vector representation of the law. First, let's understand the important features or characteristics of the gravitational law. You know the gravitational force is given as G m1 m2 upon r square. That is, it is directly proportional to the product of masses and inversely proportional to the square of the distance between them. Apart from this, the gravitational force does not depend on any other factor. I mean, if you keep the two masses in vacuum, or you keep it in air, or you keep it in inert gas at that constant distance, it doesn't matter. And this is nothing but the first characteristics of the law. That is, the gravitational force is independent of the intervening medium. It does not depend on the medium in which the two masses are kept. The second important characteristics is the gravitational force is a conservative force. Conservative force. When I say conservative force means the work done related to this force is always conserved, or the work and energy related to this force is conserved inside the system. I'll make you understand this in depth. Let's say the opposite of conservative force is non-conservative force. I'll take one example of non-conservative force. Frictional force. Now when work is done with respect to the frictional force, means if I consider two surfaces rubbing against each other, then a lot of heat energy is produced. And that heat energy is dissipated into the surrounding, means it is lost out of the system. The energy is not conserved inside the system. So that kind of a frictional force is called as a non-conservative force because the work or energy is not conserved inside the system. In a similar way, if I consider this gravitational force, any work done or energy related to gravitational force is conserved inside the system. It could be energy stored in the form of potential energy, or it could be kinetic energy with which the two masses start moving towards each other because of the attractional force. So hence it's called as a conservative force because energy is conserved in the system. The third important characteristics of gravitational law is the force exerted by first particle on the second particle is exactly equal and opposite. Remember this, equal and opposite to the force exerted by the second particle on the first one. What does that mean is, if I consider myself as one mass and earth as the other mass, then the magnitude of the force experienced by me because of earth or earth because of me will be the same. It is not that earth is going to experience more attractional force or I am going to experience more attractional force. No, we both are going to experience the same attractional force if we are kept at a constant distance. Only the direction will be opposite. Clear? Then the third important statement is gravitational force between two particles acting along a line joining the two particles, means this force always acts along the line joining the masses and it's an action reaction pair. So clear with the characteristics? Let's move on to the vector representation. How do you represent the gravitational force in a vector notation? Let's visualize. Let's consider m1 and m2 as the two masses, and let's say F21 is a force experienced by m2 because of m1. So you know, a vector is always represented in two parts, a magnitude part and a direction part. In this case, our vector is F bar 21, which is nothing but the force exerted on the particle m2 by the particle m1. So F bar 21 is equal to, now what will be the value of the magnitude of this force? According to Newton's law, the magnitude is G m1 m2 upon r square. Into direction. Now direction over here is given by a unit vector. You know, a unit vector is a vector which has got a magnitude of 1. It is only for the direction representation. Here, let's say u bar 1 2 is that unit vector whose direction is as shown in the diagram. You can see that blue arrow. Okay, u bar 1 2. So u bar 1 2 is a unit vector drawn from the particle m1 to m2. And in totality now, we can just write it properly as F bar 21 is equal to G m1 m2 upon r square into u bar 1 2, and this is the vector representation of f bar 2 1. Similarly, we can represent f bar 1 2 also. Now what will be f bar 1 2? It will be the force exerted on m1 by m2, and as it's a vector, it will be having a magnitude and direction. So f bar 1 2, which is shown in the diagram, okay, will be equal to the magnitude. Now magnitude part, you remember the Newton's law, the magnitude will be what? G m1 m2 upon r square into direction. Now direction, again I will take another unit vector, a unit vector represented as u bar 2 1, whose direction is as shown in the diagram. Okay, you can see that blue arrow, u bar 2 1. So here in totality, f bar 1 2 is equal to G m1 m2 upon r square into u bar 2 1, and this is your second vector representation. If I just cumulate these two forces, just look at f bar 2 1 and f bar 1 2. Both these forces have got same magnitude, G m1 m2 upon r square, right now? So they've got the same magnitude. But look at the unit vectors. The unit vectors are opposite in direction. So can I say these are equal and opposite vectors? And if they are equal and opposite vectors, I can write f bar 1 2 as minus f bar 2 1. Okay, the negative sign indicates that both vectors are in opposite direction. Clear with the vector representation?